Hey everyone, first of all, thank you for choosing my introduction to IoT and basics course. I am truly excited to have you here and thrilled that you have decided to start your IoT journey with me. Whether you are a beginner or someone looking to expand your skills in the niche, this course is designed to help you explore and understand the fascinating world of Internet of Things. Your support means a lot to me, and I am here to guide you with every step of the way. Once again, thank you for being part of this journey. Let's get started. This chapter focuses on introduction to Internet of Things, basic components of Internet of Things, and how they come apart. Here are the topics that we are going to cover in this chapter. We'll cover what is IoT, we'll deep dive into components, we'll see how IoT works, what are the components inside IoT, how these components will come together and basically work with each other. And we'll also look at why IoT is important as well, why you should pick it up as a career. We'll see some trends in the industries, we'll see some key sectors that are impacted in the IoT. We'll also see future of IoT. We'll see some numbers around them, how it is being picked up in the industries, what are the implications, and how it is going to turn around. Let's get started. What is IoT or what is Internet of Things? If you were to type this on Google, this is the definition that you would get. Internet of Things or IoT connects everyday physical objects to the internet, allowing them to send and receive this data. Now, you might have heard about IoT on YouTube. Maybe somebody has posted on LinkedIn, might have come across through tech journals, newspapers, or you might have some seen publications that are posted by companies or industries, or it may be already something which is already getting worked up across your universities or the places that you're working around. Now, this is a very crude example of IoT, and there's a very crude definition of Internet of Things. And we'll, in the later stages of this course, we'll deep dive and understand each and of those components. How are these connected together? What are physical objects? How they exchange data? And we'll see around with some examples. Now, this is one of those examples. Now, you already be aware of smart bulbs in the market, right? Those are Wi-Fi connected bulbs or BLE connected or Bluetooth connected bulbs. There are some Zigbee connected bulbs. What happens is when you press the button, the light will turn on. This is a really good example of IoT. A very common example of IoT. Let's look at another example. You might already have thermostats at your homes that is provided either by Google or Amazon. There are Nest thermostats, there are third party thermostats. It may or may not be connected to internet. I'm just taking an example of interconnected thermostat here. So what happens if the temperature goes above threshold value, your AC will turn on or your HVACs will turn on. Same with your heating appliances as well. When the temperature drops, the heating may automatically turn on to maintain that temperature. In today's cases, it happens over the internet. You don't need a physical connection between this thermostat and the air conditioner. Let's look at another example. Your smart speakers are really good example of internet devices. So when you speak to your smart speakers, let's say when you ask them to play music, and if it is connected to Spotify or some kind of other uh, music services, it will start streaming the music. Or if you ask them to do specific task, if you ask them for weather, they go on the internet, fetch the data, and basically respond to you. There's also an example of internet things devices. Your Fitbit or your Apple Watch is another really good example of IoT. It tracks your steps, it tracks your heartbeat, it tracks how you are sleeping, it tracks your meds. And this is the data that is available, let's say, on your phone. And when you try to access the same app with the same account on other phones, the data is also visible. Data is residing somewhere in the cloud. And though your Fitbit or your Apple Watch may not have internet, but it has a Bluetooth connectivity with your smartphone. And in returns, that it basically pushes all this information on a place where we call it cloud, and from there you can see this information in all your apps. This is also a really good example of an IoT device. Now, these things may or may not talk to each other. Things like for your smart speaker, your smart bulbs, your HVACs, thermostats, your Fitbit, they come together and probably talk to each other to form a network. These are called things, and they may communicate with each other through a cloud. And this exactly is what forms Internet of Things. Things representing your HVACs, thermostats, your smart bulbs, your smart speakers, or any connected devices that exchanges this information over the cloud. And this cloud, along with the network of your things, is exactly what is forming Internet of Things. It may or may not talk to each other. For example, your Fitbit may have some kind of trigger to your smart bulbs. So, for example, if you are not taken enough steps that day, the light will start blinking red or green. You can configure that using some kind of integration software. It's similar with your Alexa device as well. Let's say somebody is at your door, somebody basically presses the doorbell button, and your Alexa will basically broadcast this that somebody is at your door, and your phone also sends a notification that somebody is at the door. So these devices are essentially talking to each other. This is what forms or interconnects. This is where the exchange of information happens, and that is why it is called Internet of Things. Now let's see how it works. How does the IoT work, or how does the Internet of Things work? So IoT lets devices like lights or appliances connect to the internet so you can control them and they can share the data. That was what was happening in the previous image that I shared, right? So let's deep dive into some of the components of IoT. Now there are essentially four components in IoT. One part is core part, or one core part is sensors, devices, and controllers processor. We'll deep dive later into that. Then we have protocol and connectivity, the way that they are talking to each other. You have cloud and data processing. It's like a place where they are essentially pushing all the data, or that data is being fetched across all the devices. Now, I gave an example of Fitbit, right? Where it is sending a data on a cloud and you are essentially able to access it from any of your devices. And then you have user interface, basically a place through which you can interact with these IoT devices or see the statuses of these IoT devices. Again, we will deep dive along these components later in the chapters. Now let's start with the first component, or one of the components, sensors, devices, and controllers. Let's deep dive into sensors first. What are exactly are the sensors? Sensors in IoT are like body's sense organs, detecting changes in the environment and sending changes or sending action or sending signals for the action. Sensors help in sensing environment and things in the environment. Now, what does that mean? Now, for example, if I were to take the example of your body parts, your tongue is one of the kind of sensor. Your eyes are kind of sensors. Your ears are one of the kind of sensors. Your nose and your hands are also one of the sensors. For example, you can use your tongue or mouth to detect acidic minerals in the water. You can taste different kind of food. You can distinguish between food. You can distinguish between what is sweet, what is salty. You can use your eyes to recognize colors. You can recognize faces. You can recognize patterns. You can recognize objects, animals, and do a lot of things with your eyes. Similar with your ears as well. So you can detect audio, you can sense vibration that is going on in other rooms. So, for example, if drilling is happening in some other room, you can not only hear it, but you can also sense that vibration. Then your nose is another really good example of a sensor. So you can detect bad odor, you can detect between different smells. You can smell perfumes of different people and distinguish between. You can detect smoke. It's similar with your hands as well. You can detect changes in temperature. You can detect pressures, you can detect touch. So essentially, all of these organs act as a sensory device and are sending signals to your brain. Now, equivalent of this would be following. Your tongue is equivalent to a pH level detector or water quality sensor. That is basically part of your water purifiers. So it may tell you what is the quality of the water. Similarly, your eyes also has equivalent sensor like a motion sensor that you have seen in malls, that once you walk in, the doors will automatically open. Similarly, cameras are really good example, or that is something that we are trying to mimic as your eyes, that we are trying to capture high resolution camera, or the images from resolution camera. Similarly, your ears are one of sensors. The equivalent would be accelerometer or gyroscope that can detect gesture, that can detect orientation. Similar way, your microphone is an equivalent of ear sensor that can basically detect audio. There are some microphones that can also detect high frequency noises, which your ears cannot do. Another equivalent is nose. You can detect nose to smell smoke, right? Similarly, you have smoke sensors in the kitchen, and then it can also detect odor, it can detect smell, it can detect AQI, it can detect ammonia, false, or that kind of very bad smell odor. And essentially, you would know what is going on. So equivalent for that is AQI sensor and smoke alarm that you find in traditional homes and offices. Your hand can detect pressure and touch, as we had already discussed. The equivalent is the temperature sensors that is very common among your HVACs, air conditioners, or any temperature-based appliances like heating appliances. Similarly, the equivalent for your hand sensor is capacitive touch that you have in your phone. Or the other example would be pressure sensor, right? So if you have ever sat in a car, and if you're not basically putting the seat belt, it will keep on beeping noise, right? So there is a very irritating beeping noise. It won't turn off until you have put on your seat belt. So there is a pressure sensor that sits just below your seats that is detecting if somebody is sitting there or not. So there are equivalent of sensors that basically mimic our body organs, right? So these are the five major sensors or type of sensors that sensors try to mimic. There are very other different kinds of sensors that essentially there are sensors that can see through walls. There are sensors that can detect leakages. But there are other thousands of types of sensors that are used in IoT industry. So I'm just going to cover few of those sensors which are relative, which are commonly used. And as we progress, or as you progress later in the chapter, and as you explore, you will find out that there are other different thousands of types of sensors that are essentially used to collect data and relay some information. Now let's look at devices. What exactly are devices? So devices, like the body parts, perform tasks that create meaningful interaction, from controlling machines to providing user feedback. Now, it's essentially an actuation device. Like when your motor turns on automatically, that's an actuation process, right? Or when your lift goes up and down, that's also an actuation process, right? When your car moves, that's also an actuation process. So anything that actuates are called devices. For example, your legs and your hands. You use your legs to either walk, run, or you use it to squat. These are actuations. Similarly, your hands, you use it to pick it up or you use it to press. These are also actuation, right? So similar way, like your legs, like if I were to talk in terms of electronics or IoT, your LED can be an actuation device. So for example, when you put up a charging cable on, or if you have seen those older chargers where they will have some kind of LED indication to indicate that the charger is on. These are used to actuate or signal that something is happening. Similar way, your motor also is an actuation device. So, for example, if you have some kind of store water storage system, and you turn on the pump, and essentially it fills the water, and it automatically turns off. That's also an actuation, that it is turning off and on. Similarly, with your hands, you have speakers or buzzer. If you have seen so those smoke detectors, it will have some kind of buzzer and LED. When it detects the smoke, it will basically beep the buzzer, or there is some LED signaling. That is also an actuation. So IoT, basically actuation in IoT is essentially something that is triggering, or something that is doing or actuating. It can be light bulbs, it can be HVACs in previous case, it can be Alexa. So those acts as a actuation device as well. Now let's see what is controller or processor, right? The brain in IoT is like the controller or processor. It thinks, makes decisions, and sends instructions to other parts, devices, and senses to act or respond. Now, if I were to give any relative example, think it of it as brain of any system. Any IoT system or edge IoT, device will need some kind of brain to process it. So, for example, in our case, what happens when let's say there is a hot water, right? A can of hot water, and you put your hand in that. What happens? Your hand basically immediately sends a signal to your brain that you need to basically take back your hand because it is hot. Now, think of IoT as in the similar system, that it may have some kind of temperature sensor. When the temperature goes up, it is continuously sending signal to the brain that something should happen, and in that case, it either that there is a lid might get closed, or it will immediately start some kind of cooling system, right? So your brain equivalent in the IoT system is either a CPU or some kind of controllers. So I'm not sure if you have heard of Arduino boards or ESP32 boards. So these are basically small microcontrollers that acts as a mini computer where this processing can happen. And user or as somebody who builds IoT system, you have to program it, right? If this happens, this should happen. For example, if temperature goes above threshold, then this should happen. If the temperature goes down, then this should happen. This actuation, this programming can done into these small microcontrollers and processors that will enable those IoT systems and make them smart. And these are also essential in sending data on the cloud as well. So you want to send that in specific format, if you want temperature in Fahrenheit or Celsius. So these are capable of doing some amount of processing at the edge. Now there are also some advanced processors that can even do a lot of good computation. So on edge, for example, it can detect faces, it can detect patterns. So it doesn't have to be sent on cloud to do that. Now, don't worry if you're not able to understand the components like cloud and database and what we are basically talking about. In the later stages, there is an architecture that will help you to fragment these components into smaller units, and will try to understand them individually. Right. So this was about sensors. Now, if I were to take some examples around controllers and processors, your eyes, your legs, your mouth, your hands, ears, and other organs essentially are sending data to your brain, the form of sensors, and then in your brain basically actuates your legs or hands. The similar way, I gave you a simple example of you touching hot water and using your hand as an actuation device. Now, if I were to combine this or understand in the context of I, this is where, or this is how it look. You have Arduino or CPU in between, and temperature sensors, microphones, pH level, motion sensors, speakers are connected to your Arduino. So, in one context, for example, if the temperature goes down, your Arduino or your controller, what it will do is it will send will send some output on the speaker that the temperature has risen, right? Or it will start blinking an LED, or it may even start with motion sensor. So these are some of the actuations that may happen in IoT, right? So for example, like we will see some industrial examples as well, alongside this chapter, that how these basic concepts are used in IoT. So these are the core concepts. It's actuation, sensing, and then there are other components like cloud and all. We'll see later. But the at the core, this is what industries use. Even if you take oil industry, even if you take agriculture, it senses something, sends data to some kind of processor or controller that will take then some minor decision to either send it on cloud or do some actuation at the end. For example, if moisture in your field, right, agriculture field, going down, then it will automatically start the pump. So this is just one very crude example. This is the concept, this is the base like concept. If you are able to understand this concept, understanding IoT becomes much more simple. Now let's understand protocols. So protocols are essentially a set of rules and regulations, if you were to define that. Now, in the context of IoT, it's the way that your devices are communicating with each other or sharing the data, right? So I will basically explain this with a very crude example. Let's say you know Spanish, and you ask an individual a question in Spanish, and that individual basically responds in French. Now, the problem is neither he understands Spanish and neither you may understand French. So, how you are going to communicate with each other? So, you might naturally ask that if either of you, you know English, and when you respond in English, you take it as a common language, then you are able to communicate. It's similar with IoT devices. So, for example, if there is a device A and there is a device B, so when they are communicating with each other, they have to define a common way through which they can communicate. It can be like how many words I will speak, the number of words I will speak, the way that you will respond, what time you will take to respond. These are some nativities in the protocol in terms of IoT context or embedded system context, right? So this is another example. Now, you know, as I pointed it out, that there is some mutual consensus that is, established between the individuals, that we should speak a little slowly so that we can understand each other better. We should dedicate the pause time, the time between each sentence is finished, and add some code words, add some start and stop words, so that you form a mutual consensus. And if that consensus is also common among all of your friends, let's say you have friends from all different countries, you have friends from India, you have friends from Spain, you have friends from Morocco, and everybody decides that this is the way that we are going to talk to each other. These are the specifics that we are going to take care. This is the pause time. This is the language. These are the, you know, mutual, spots where we would start and, stop speaking. This is what forms a protocol. And based on this protocol, then it becomes easier for you to communicate, to exchange the information. And IoT exactly works in the same way. Like the protocol in the IoT works exactly in the same way. In the context of IoT, there are essentially two types of protocol that are commonly used. One is the networking protocols, and one is the communication protocols or data transfer protocols. There are also different kinds of protocols that are involved at a deeper level, but we essentially don't have to really understand it unless we are trying to build a complex system, or where we are trying to design a very robust and highly scalable system. It's always pays off to understand technicalities of it. But for this course, let's stick to something that is very commonly used and that you would be doing hands on in case you want to learn IoT, right? So network protocols are used to establish communication between IoT devices and various networks. Might have some devices which are working on Wi-Fi, Zigbee, Bluetooth, and some other different kinds of communicate or different kinds of networks or protocols. So they essentially need to communicate or connect with internet in order for it to exchange the data or information with other devices. So these are usually done by network protocols. And then you have data transfer protocols when devices are communicating with each other. Let's see some examples. Now, for network protocol, let's say you have internet and you have a smart bulb which is Wi-Fi enabled, and through Wi-Fi it connects to your local router that gives it access to the internet. And you may have a smartphone that basically you can, turn it on, or press the button to turn on the light bulb. Similarly, you have your Fitbit or your Apple Watch that doesn't have a Wi-Fi, but it may connect with Bluetooth through your phone, and it is essentially sharing the internet, or your Apple Watch is able to get access to the internet through your smartphone. Now, let's say for example, you have a home where you have like two or three floors, and very difficult for Wi-Fi to reach across all the rooms. In that case, some kind of local protocol is used, to enable devices to communicate with each other. So your motion sensor, your PIR sensor, your refrigerators, your temperature sensors, they all communicate with each other. Let's say through Zigbee, which is very common among mesh devices or nested devices. Now, these devices will talk to a master gateway, and that in turn will talk to a Wi-Fi router that gives it access to the internet. So, network protocol lets your devices connect to the internet directly or indirectly. So, it can be any kind of protocol, right? Depending upon use case. So, for example, in the second case where you have a smartwatch, so most of the time you have your phone with you either while sleeping or either while on your desk and all. So your smartwatch is able to access the internet through Bluetooth. It doesn't need any complicated network protocol in order for it to access internet. And Bluetooth is also low power, so it is really suitable for battery based devices. But on the last case where you have very like high mesh of devices that needs internet, right? So, and your Wi-Fi may or may not be able to support these many of devices. That's where they will communicate locally through some kind of protocol like Zigbee, or even BLE supports that. and it connects to a gateway. Now, this gateway is responsible for collecting data from all these devices. If you're seeing this, so these devices will send or receive data through the gateway, and this gateway is basically talking to your router and trying to, or it will gain the access to the internet, and that's where it can then send data on the cloud, from where it can come to your smartphone, smart devices, Alexa, Google Home, and all the interfaces through which you can access these devices, right? So if I were to just take the same example, now your gateway, through your router, through your Wi-Fi router, your smart bulb is essentially communicating to the IoT cloud. Let's assume, right? So this black thing is, let's assume this is an IoT cloud. So your bulb is essentially sending data or some kind of status that, hey, I am, on, or I am off, and this is done through MQTT. MQTT is one of the communication protocol. And similarly, you have, these are communicated either through your these gateways or through your smartphones. So communication protocols are responsible to let your devices talk to each other on the internet and locally. So as I already suggested, that if I want to upload data on the cloud, or if your devices want to talk to your IoT cloud, it needs some form of protocol, that this is how we will send the data, this is the frequency, this is the pause, this is the number of bits or the number of data that I will send at a given instance, so that you, or your IoT device and your cloud or other devices should be also able to understand that what each of these devices are trying to communicate. Here are some common protocols that are used in industry. So we are not going to deep dive into that, but you might have already heard it. So HTTP, which is very commonly used protocol. You may be accessing websites through HTTP or HTTPS. TCP is another protocol. A lot of audio or real time data fetching or streaming is done through TCP. MQTT is another messaging service or messaging protocol. Then in network protocols, you have Wi-Fi, Zigbee, and LoRaWAN. LoRaWAN and Zigbee are used for a wider, network, where you have a lot of localized devices, where you cannot give Wi-Fi access to each of those devices. In that case, LoRaWAN is used. So it forms a local network, and also the range is very high in that. In agriculture, in industrial spaces, LoRaWAN is quite common, and Zigbee is common among your homes. Possibly, if you live in Western country, it's possible that you might have already these kind of systems stored in your home. Now, I have been talking about cloud, in the previous chapter, right? So you may or may not know cloud, right? So if you are, using some kind of iCloud or Drive, or some kind of Microsoft OneDrive, then you are already using cloud. If you are using a place where you can store your files, and that files you can access it from anywhere, that in itself is cloud. Now, speaking in terms of IoT context, the cloud is a network of remote servers that store and access data, providing on demand access to resources without local infrastructure. So what does that mean? Let's see. Example is just a computer on the internet. So think it like a computer where you put your files, and that computer, you can access it from your phone, you can access it from your iPad, your Mac, your computers. So you're storing that information on some kind of computer that is connected to the internet, and that computer is accessible to you from anywhere in the world. Now you can store photos, you can store files, but in IoT context, for example, your Fitbit data also goes on cloud. Your smart bulb status, like if it is on and off, it also goes on cloud. And that is the reason you are able to access it from anywhere. You can access it from your phone, you can access or control it from the phone. So that means you can change anything in the cloud using your end devices, and your IoT devices can also update, alter, and get the status of the data, right? So let's see it with an example. So let's say you have some photos, You went outside with your friends and you have clicked some photos, and you go in the garden and you want to, let's say, access those same photos, and but it's on your desk sitting on your computer, right? So that becomes a problem, right? You don't have access to those photos anymore. So what you do, essentially, upload this data on a server on a computer using your MacBook, right? So these photos are then accessible through your smartphone. I would say a copy of those photos is accessible on your smartphones, and same instances can also be shared with your friends, right? So you upload that data or you upload that photos on the cloud that is accessible to you, to your friends. You can share it. You can reshare it. Your friends can share it with their uh, you know friends as well. That is called a cloud. All right. With this same context, let's try to understand what is an IoT cloud, right? So, what we'll do is we'll try to understand this with an example. Now, we will take our initial and the first example where you had a smartphone and basically connected to a smart bulb, and when you press the button, it essentially turns on the bulb, right? This was the very crude example of an IoT device. What we'll do is in the next few minutes, we'll try to extrapolate. We'll try to break it and fragment it down, and we'll increase the number of components that comes between. We'll insert some of the things that we have already discussed in the beginning. For example, let's extrapolate it. So you have a smartphone, you have a smart bulb, and it has some kind of IoT cloud where you press the button, the light turns on. So in the previous, it was just direct communication, and we have integrated a component, which is essentially an IoT cloud or some kind of system. Now, let's try to extrapolate it more. So you have an IoT cloud, some kind of computer which is sitting on the cloud, and your essentially smartphone is either connected through a Wi-Fi, and same is with your smart bulb as well. It may also be connected with Wi-Fi. And once you turn on, the bulb will also turn on, right? So there's another component which is a network protocol, which is Wi-Fi, that is essentially helping your smartphone and your bulb to connect to the internet, and they are exchanging this information through a cloud or through a computer that is residing in the cloud or which is connected to the. Now let's extrapolate this a little bit further, right? So you have a cloud, you have a computer on the cloud, you have your smartphone, you have your bulb, and your smartphone is connected towards Wi-Fi through Wi-Fi, and it is connected to some kind of router, Wi-Fi router, and it is accessing data on the cloud. It also is using some kind of. It can also use some kind of 4G network or 5G network connect to a network tower, and it's essentially accessing the same cloud, and that in turn is basically controlling your bulb which is connected to Wi-Fi, right? And this bulb is connected to a smart device like a brain that we saw initially, right? So in the section where we were trying to explore controllers and processors, so your smart bulb is essentially connected to a processor. You may not see it, you may already have seen a smart bulb, but the processor is inside the bulb. There is some kind of intelligence circuit that is inside that enables this bulb to connect to a internet through Wi-Fi, and which is also connected to some kind of router, and that in turn is accessing the same computer which your smartphone is accessing. So through the smartphone you are changing some certain variables, that okay, turn on the light, or you are using network to connect to the or to control or to connect to that internet computer, and that essentially sends the signal to the bulb or to your intelligent device that you should turn on the bulb, and this is what is happening. Let's extrapolate it a little bit more. Have your phone, you have your embedded device that is connected to your smart bulb, and you have internet. On the internet, you have a computer. Now, in that computer, you have some kind of database. Now, database, imagine it like a spreadsheet. So this spreadsheet essentially, has some kind of field that enables you to change this specific field, right? So, for example, when I my phone is again through Wi-Fi, it is accessing a small piece of code that is responsible to essentially change this spreadsheet field, right? And it may have some kind of authentication mechanism so that nobody else can turn this light on. It has to be you. It should have some kind of login system or some kind of identification system, right? So, for example, if you download the app, some kind of smart bulb app, it will ask you to log in onboard the device so that only you can control those devices. So, there is some kind of validation layer in the cloud itself that restricts access to this database, right? And this is also connected, this piece of code is also accessed by your edge device or bulb, right? When you turn on the light, what essentially happens is it sends a signal that you as a user, you want to access the specific bulb which has, let's say, ID number 1, and I want it to turn on. So it will send that piece of code. The code will basically validate if this is the user. If, like, say my name is Vivek, so it will try to see if this is Vivek. Okay, Vivek has permission to enable or change this specific field. And what it does is it changes this field to on. What happens is then this signal is also sent to the bulb. So basically, bulb, or the smart bulb knows that my ID is 1. So once the user changes this ID 1 to on, the bulb will know, okay, my ID was changed or my status was changed to on. So I have to turn on, right? Now, this is what forms, or this is how the IoT system looks slightly on a deeper level. Now, if you were to dissect this further, it also comes with a lot of other components which may not be or would be too much for a beginner, right? So I think this is something which will help you to understand components at level, right? You have Wi-Fi, you have some kind of network layer, you kind of have some kind of communication protocol that the smartphone will communicate to bulb or change the details. You will have some kind of validation layer, you have some kind of cloud, and you have some smart system, some smart bulb that is essentially turning on when you hit a on button on your. This is how the IoT system works. The sensor will also work other way around. So imagine this bulb as a sensor, it will be reversed. So basically, it will go back, it will change the field of the sensor, and your smartphone can also access the same field. So let's say if you have a temperature sensor that is changing something, let's say there is a change in temperature from 30 to 28 degrees, the specific field will be updated, database will be updated, and the same is reflected in the smartphone. Let's look at the next chapter. What is a user interface? Is the last component of IoT that we all. So the user interface in IoT is the medium through which users interact with devices such as screens, apps, or voice commands. It allows user to monitor, control, and receive feedback from connected devices. Now we have seen several examples in the beginning of the chapter, right? So if you remember a smart bulb, you were using a phone to turn on the smart bulb. That is a user interface. And when you were speaking to your speaker, right, the smart speaker, here the interface is voice. It's a voice interface. It's essentially allowing you to change some parameters or get the feedback, right? It's a medium through which you can receive and send data, that is tangible, that is physical, that you can see or hear, right? So it's just a screen that makes it easy for humans to interact with technology. That is what is called as user interface. Now, to see some examples, let's say you have a temperature sensor, and when something changes, you can see that in the interface. The same can also be applied in the buttons as well. So if you turn off the lights or turn on the lights will turn on, right? Let's put out the old architecture using which we had tried to understand the components of IoT, right? So this is something that you had seen, that you have a button using which you will turn on the smart light. In this overall component, this specific part is called user interface. A button, a screen, a website through which you can talk to your IoT devices is called a user interface. So you might have interacted with websites, maybe some kind of GUI where you can see charts and graphs. So in terms of fitness band, you can see that in your phone. That is what is called user face interface or user interface in the context of IoT. Now, why exactly you should learn IoT or why you should pick it up as a skill? Now, this is a very crude number, right? So there are the market is going to be around $4,000 billion by 2032. So what this means is there will be a lot of job opportunities for everybody in this field, for educators, for teachers, for back end, front end developers, for SMEs. There's a lot of going to be a lot of other job opportunities that are going to be created using this market, and this is quite a matured field. It is something which is already being used in industry. There are a lot of use cases that have already been proven to provide a really good return on investment on the IoT side. So it's a natural extension that it is as big as an AI market. It is much more or highly matured than AI market. It's already widely adopted. You have a lot of devices around you. Just think around, or think around the devices that you're using. Your phone is an IoT device. Your smart speakers, your sensors, actuators, traffic lights, your fabrication units, your manufacturing units. Almost everything is IoT enabled nowadays, and this is going to be increasing, right? It will compound to over $4,000 billion, which is a huge market and a huge scope of getting money. We'll in the later stages of this chapter, we'll see what are the job opportunities it will create, and we will roughly see that how each of those jobs would help you earn. So whether you are a business guy, you are into any of the sectors, it doesn't matter. IoT is eventually going to touch all of your lives. Now let's look at some opportunities and areas, right? Smart cities is one of the aspect where you will have a lot of things like traffic, weather, and a lot of other things, infrastructure, energy that are being enabled through IoT. Healthcare is another sector where it is being picked up heavily, like remote patient monitoring, telemedicines. There are now apps that lets you enable that. There is some kind of health analysis system where it will detect blood pressures, your blood, or your sugar levels, and it will update that on the cloud, and doctor can directly see it from anywhere in the world and suggest medicines. Agriculture is another aspect where it is hugely being adopted. So from getting the plant status, moistures, water, harvesting, all these things are independently monitored, controlled through Internet of Things. Manufacturing is another huge sector, right? So whether it is car manufacturing plants or some kind of appliance manufacturing plants, real-time monitoring systems and predictive maintenance is something which is empowering these industries. Transportation and logistics is another field where IoT is aggressively used to track the fleet, to track the status of their packages, status of the trucks, cold storage management system where you have to maintain a specific temperature to transport some goods. It can be medicine, vegetables, and this is all being monitored by Internet of Things. So monitoring is one aspect, and based on that, based on the data that it receives, you can take intelligent actions. So for example, in smart cities, it can be if somebody breaks the signal, it will automatically send or bill you for the same. In healthcare, it can be just sending the health data and making it available to the doctors in real time. In agriculture, it can be calculating when it needs water, when it needs nitrogen or some kind of other fertilizers. Manufacturing is also same, that it can detect predictively tell you that if these things are going to go wrong, right? So for example, there has been a motor that has running for a long time on a conveyor belt, and IoT systems are enabling it to ensure that the the plant manager is able to identify in next 2 months this motor is going to break down. These are the indications, and they can save the cost on that. They can predictive or early maintenance. Same for transportation. You have cold chain monitoring system, where, medicines and everything, right? It has a stamp, or it has to be temperature controlled. Some goods have to be temperature controlled. So those things can be monitored using IoT. Let's deep dive and look at the each of these use cases. There's a bonus chapter in this course for the smart cities, right? So you have street lights, right? So based on timing, it will turn on. So what happens is during duration, uh, during the duration or during weather change, the night and day time also changes. So for example, in winter, the night might come early. So based on weather predictions, based on the sensor data, if it is dark or it's already light, street lights can be turned on, right? Same with security cameras as well. So if something goes wrong, it can, now there are AI enabled cameras that can also detect patterns, or if people are carrying gun, the smart camera is enabled, can track it and basically inform the security forces, and they can take immediate actions, right? Then there are smart energy monitors for building. So in building, basically it will calculate that this is your power usage, and it can give a comparison that in the last month you had consumed this much. Based on that, you can take action if my either of the appliances are not working properly, or because my energy pattern is changing. It may be based on weather or some other factors. And then you have traffic lights. So based on the traffics around the city, or let's say if ambulance gets stuck, all the traffic lights along that path will turn green. This is already being done in Dubai, in US. A lot of places it's already automated, it is intelligent, it is AI driven, right? And then there are smart weather monitors across the cities that will tell you AQI values, or how the weather is there in the specific spot. Based on that, you can take action, right? So AQI, temperature, humidity, these all parameters affect your energy pattern, energy usage, when you should turn on the window, or you should turn on the air purifiers. And it can also detect hotspots. So these are few examples of smart city, IoT being used in smart city. Another example would be smart bus management or fleet system, where you have local city buses or intercity buses that travel, and you can basically track it on your phone, and you would know the position of the buses, right? Based on that, you can time it, you can time your travel and save time in there. So it is either saving time or saving cost for you. And this is what enables the smart cities. These are some common use cases in smart cities. Now let's see some examples in healthcare. Have telemedicines, where doctors essentially prescribe you medicines for the internet. Have some kind of video conference system, where would be given a small suitcase kind of thing, where it will have some health sensor devices. It may have blood pressure machines, or it may have your sugar level indicator, where you could just take a blood sample, put it there, and it will tell you the blood sugar. And this all gets uploaded on the internet. So before the call, the doctor will exactly know what is your heartbeat, what is your sugar levels, what is your blood pressure, and based on that, it can detect, or they can tell or suggest the medicines. Then you have remote surgeries, which is already mainstream. Like a lot of heart surgeries or open surgeries can now be done through over the internet, so that the specialist who may be sitting somewhere in, let's say, London, and they have a machine that is in US, and the surgery is going on in US, and doctor who is in London can use a specialized device to control these robots that can essentially do the operation and do this surgery. Then you have a health monitoring system that I had already explained, or even in in hospitals, where you have some kind of health monitoring system hooked up with you, and in case anything goes wrong, your vitals can directly be sensed and detected or seen by the nurses there who would be sitting around in reception. And in case the system is equipped enough so that it can trigger a notification, and nurses or doctors can take the required action. So it is responsible for saving a lot of life. It is already mainstream. A lot of good hospitals are already using this kind of system. Similarly with agriculture as well, right? So now you can see plant health. You have cameras that can take photos of the plants and detect what kind of disease they have. The previous chapter we had already discussed how camera is also a kind of sensor, and using some intelligence you can actually detect some patterns on the leaves if it goes bad. That can also be an early indication to the farmers that can help them to segregate the bad crops and enable them to take immediate action with some kind of fertilizer or medicine that they can apply on plants. Then you have smart watering system, some kind of sprinkling system that can be timer based, that can also detect moisture or certain indicators using which they can basically enable watering of plants, right? And then you have nutrient and moisture analysis. Now there are sensors that enable you to sense nutrients in the soil, right? Nutrients in the water, and based on that analysis you can it can send some smart notification to the farmers that okay, you can use this specific fertilizer, or you'd have to use this specific nutrient, right? This plants are low on nutrients, and based on that they can determine plant health and take immediate action, right? And you have precision farming. So this also saves costs on a lot of other things. They can save cost on water, they can save cost on fertilizers, so that the farmers don't overdo things that are required on the crops, right? So these kind of system are already saving a ton of money for farmers across the world, and it is enabling them to get more out of it. And disease detection is one of the topics that I spoke about. So apart from plant health monitoring, you have certain diseases that are intelligently captured through either camera, or there can be some indications, so that for example, in a spot the nutrients might immediately go down, or nutrients may directly go up, or fertilizer level immediately goes up. So these are all things that can be now monitored through certain sensors that are available in the market. And there is farming automation now. So there are vertical farmings, horizontal farmings. There are farms which are completely automated, or at least semi-automated, where the let's say your fruits are automatically picked up by robots. They define, or they detect colors, they detect the pattern, they detect the size. Based on that they will pluck the fruits, right? And there you have some kind of automated system for green veggies, where it acts like a conveyor belt. So for example, your lettuce or some kind of other greens, once it matures, everything is monitored by IoT. The height, the length, the photos, when it was put, when the seeds were incepted, all these things can now be automated, and the produce is taken out directly. Now there are really big robots, farm robots that work on agriculture land, that are autonomous, and you just have to feed it that this is your area, and those robots will automatically go take out. Let's say if you have plant wheat or corn, it will automatically pack it, and at the end you will receive packed stuff that you can then send for pre-processing. So automation at this level is already done, and a lot of farmers are using especially in west, a lot of farmers are already opting out for completely automated farming, where you have thousands of acres of lands are automated, intelligently monitored. Now in manufacturing sector, it's already being used. This is something which is quite older. Earlier it was not automated or IoT enabled. Now they have completed everything together, and it forms a really good network that enables them to do a lot of things. So predictive maintenance is one of the aspects that I'd already explained. So in factories, you have a lot of moving parts. You have robots, you have motors, you have turbines. So there are certain sensors that can detect the vibration in the motors. They can detect the pitch in the motors. They can detect high frequency noises. For example, if metal are clashing with each other, right? Let's say there is some bearing fault, or bearing is essentially wearing out. So those are essentially not detected by humans. We cannot hear those, that raging noise, or when they basically clash with each other. So there are very, specific microphones that can hear high frequency noises or low frequency noises, and they will try to define a pattern or detect a pattern. Based on that, it will tell that okay, this machine is going to stop after 2 months. This is the fault, and you can take predictive maintenance on that. So when in any assembly line, if anything stops, they have huge backlogs in terms of inventory, or in terms of what they want to produce. So it is a really, really major impact for them. And this is being used in all kinds of industries, like water, turbines, and power generation, manufacturing, logistics. So automation is another fact where based on certain actions, it's already being automated. For example, if something happens, like if a material goes from point A to point B, this should happen. So this is something which is quite old. They have just connected it to internet. So you can now create a workflow. So for example, when my X product gets manufactured, the inventory before that will automatically get updated that I need to order more inventory. So it will kind of create a flow, custom flow based on whatever your use case is, right? And then you have asset tracking and management. And manufacturing plant, it is very essential that you track each and every asset, each and every components that go into manufacturing a product, right? So this is also being tracked by RFIDs or some kind of other systems where it will know that where exactly is each asset in the manufacturing, right? Then you have waste reduction. So IoT can also track waste reduction. Similar way, based on it can be piggybacked on top of asset tracking, and they can be tracked at each of those life cycles from manufacturing to when it is incorporated in that product, or when it goes wrong, or when it is a discarded product, it goes into waste. So this is also tracked with IoT, right? It can also do supply chain optimization. As I already told you, a factory that is automated, that does end to end, that does asset tracking and management, would know how do I maintain the inventory. If like my production is automatically increasing, it will detect that pattern that my assets, internal assets are getting consumed, my components are getting consumed. So I can optimize my supply chain and automatically order for those parts with my partners. If the manufacturing goes down, then I can similarly opt out of ordering those components. And it, in fact, it can also trigger a notification. So this trend analysis can automatically be done, which is already being used in the industry. Then you have process optimization. There are a lot of things, right? For example, there are a lot of manual work which is being already automated, from labeling to uh, you know uh, detecting and then sending across. For example, Amazon warehouses. It may not be a case of manufacturing, but for example, if you have a lot of packages which is incoming, so you have conveyor belt system hooked up with intelligent cameras and brain that can identify which package is specific to where, and it will automatically send those packages or route those packages in those specific trucks. So there are robots that enable them to do that. So from when the user places an order, a robot will automatically go in the go down, find the place where that specific order is there, take it out, take it down to the conveyor belt, automatically pack it, put it on conveyor belt, put the address, and then reroute it to the place where it will be loaded in the trucks. And now even trucks are getting automated, fleets are getting automated. So that is the optimization in the process that can be achieved using IoT. And this is not a concept anymore. This is not a fiction anymore. It is being used by a lot of e-commerce, and logistics or manufacturing. Even it is used in Tesla plants. So this is quite common now. This is something which has already become mainstream. Let's look at another example of transportation and logistics, right? So have a lot of transportation system by the city. You have buses or trucks that travel outside the cities, right? So you have fleet management where you can manage and optimize the fleet, right? You have a lot of trucks. So for example, I gave you an example of Amazon. So they highly optimize their routes. They know at what time the traffic will be where, and they are pulling this data from Google Maps. They are pulling this data from multiple sources. They are pulling this data from their own trucks with GPS and IoT enabled system that lets them track where their vehicle is, and based on that they track and optimize at a level where they could deliver, or they could enable maximum deliveries minimum amount of time. It's same with also public transportation or buses, where you would know that when my bus is going to get arrived, right? So based on that I can plan it. Like if I want to leave my home, I can plan it out based on where my bus is, and I can save time, right? You can do a real time a real-time tracking system of your transport or your buses or your public transports, even for Ubers and all. They're also in a way IoT enabled, where the Uber drivers' phones are essentially sending their real-time location, and in the app you can see where the taxi is or when it is going to get arrived station. You can also do predictive maintenance. So now your essentially cars are also IoT enabled. Your Teslas 100% IoT. I mean, they constantly get the updates. Your performances can be tweaked by just a firmware update or just a small software upgrade, where they will tune in some kind of momentum or some kind of small tweaking in the motors that will enable them to increase the performance, right? And this is where the predictive maintenance comes in. So based on the number of kilometers or based on your driving pattern or anything that is detected, it is continuously monitoring the entire vehicle system, and based on that it can inform you that either your shock up has given up or either your motor is failing, and you will get the timely updates, and you would know that okay, this is the time to get my vehicle serviced, right? And cold chain monitoring is something which is I had already explained in one of the examples. Let's say you have some medicines, injections that are specifically kept at a temperature. You have some vegetables or dairy items that are kept at a specific temperature. It has to be monitored closely, because if that temperature exceeds, there's a chance that it may go bad. And this is live tracked on a phone or like on a system or on tablet on a PC. It is being tracked continuously by the owner of the vehicle, or by the manufacturing unit, or the product owners who would want this thing to reach the location safely. So this is already being tracked on the internet. This is something which is already mainstream. And then you have smart cars or autonomous vehicles. So you might have already seen Waymo, might have seen Google's car. A lot of other startups are testing their autonomous vehicles. These are essentially highly high frequency, or data frequency is very high among these vehicles, where they're exchanging this data at rapid speed. They're making decisions in milliseconds, microseconds, and enabling those vehicles to take decisions. Is detecting through cameras, lidars, radars, internally, and through detecting, navigating, taking traffic patterns, detecting where the traffic is, detecting the signals, watching over the signals. Everything around autonomous vehicles is IoT enabled. Updates and live tracking. If let's say there is a service in vehicles now. So for example, if your vehicle crashes, it will automatically call 911 or some kind of emergency number, and it will also send your live location. So this is another example of transportation, right? And with the fleet management, you could also do route optimization, that I had already explained, that based on a lot of data inputs is being taken, like maps, the live location, how the traffic situation is there, at what time the traffic will be there, the routes are optimized. So these were some examples in transportation and logistics. Let's look at some of the rules and opportunities that are there in IT, right? So if you are somebody from any background, it doesn't matter, you will always have a role to play in an IoT system. IoT consists of a lot of components. There is a synergy between lot of things that comes together and make the system reliable, efficient, and sure. And it is something which is already proven technology. It is something which is being used across all the industry. There is a huge scope of the growth. There are a lot of job opportunities that will come in this, overall uh, world, this IoT world. So I feel that everybody has a part that they can play in the IoT system, and it is very fulfilling because it's a tangible thing that you can see, feel, and experience. So IoT is slightly different from all the other technologies or newer technologies that you see. IoT is old as it gets, and it's already mature. So I will try to explain all the things that I had spoken about around components of IoT, break it down into certain things. So for example, when you mobile part, like mobile UI part, can Even if you're doing UI UX design for, let's say, software applications, you can always transition back to IoT and be a niche or create a niche around that. So you can be a UI UX designer who interfaces, how charts will look like, how graphs will look like, how they should feel, how the button should look like, right? And then you have another role to play where you are either mobile or web app developer. So essentially, you convert these screens into actual code that you can run in your website or in your phone. So UI UX designers will define how user will interact, how and where they will click, what is the design going to look like, what would be the flow, how many buttons it should take to turn on the light, or what are the configurations required, what are the best practices. And mobile or web developer, app developer can convert this into actual actionable screens, right? So these are done by app developers. On the device side, you have hardware engineer. Hardware needs to be robust, right? And this hardware needs to be designed by hardware designers. There are a lot of constraints that come together, right? For example, it has to be in specific shape, it has to do something, it has to support high frequency data, it should support camera. So these are the requirements that are usually taken care by the hardware engineer, right? They design the PCB, they design the schematic, they choose what kind of component should go on. They also take care of, it is outdoor or indoor, like how it is going to be used. And all the other things are around the hardware or around the PCB, around the smartness of that hardware, is usually taken care by the hardware engineers. And then you have firmware engineers who essentially put the logic in the hardware. So they basically create or write code in the smart devices, so that your, let's say, light can connect to Wi-Fi, it could send the data, it becomes capable. So you already have a brain, right? You have a CPU, and in that CPU you create the logic. This logic is usually done in the form of firmware. It's just a piece of code that runs on your hardware that enables you to do something with that, either actuation or either sensing. This logic is written by firmware engineers. Then you have security engineers. Initially, we spoke about that why security is important. Now, let's say if you connect the smart bulb in your home, you wouldn't like if I will turn it on just on my thing. I can prank you. Anybody can turn those lights on. So these essentially are taken care or by security engineers. They enable or they make the system smart and secure. They recommend encryption methods. They increment or they basically incorporate login, log out, user management methods, how they will sign in, how they will sign up, or how further they can secure it at a deeper level. This is done by security engineers, right? Then you have backend engineers, right? Code for this. So in the we had already explored what is cloud, right? So in the cloud itself, there is also logic that that essentially accepts data from user interface or accepts data from hardware, along that this is a sensor value or this is something that I have to control. This logic is written by backend engineers. So, for example, it can be Node.js, Python. A lot of other languages are written, can be used to create this backend code. Similarly, you have DevOps engineer that enables that smooth flow of the system. They design the system. They ensure that it never goes down. It is in sync. It is always up and running. You have very low latency. All the systems are working together fine. This is usually done by DevOps engineer. That is one of the rules of it. They do much more than that, but that is the core goal, that to ensure that systems are up and running, they are functioning, they have a really good uptime, and they are able to handle the kind of traffic that that we are expecting. And then you have database engineers. So I gave you a very crude example of spreadsheet, right? So essentially something changes in spreadsheet that enables you to either see that data or change that data in the spreadsheet, and that also is reflected when the light is turned on and off, right? So it's just not a spreadsheet, but it's slightly more complex database, some kind of place where this data is stored. So this is taken care by a database engineer, right? So this is another role. Then you have data scientists, right? So in the previous use cases we had, we had seen that predictive maintenance is there. You have trend analysis, you have pattern analysis, you have some kind of intelligence that is put, right? So data scientists are responsible for analyzing trends in that data, analyzing patterns in that data, and deriving intelligent actions. For example, I have a water heater that I will turn on exactly at 6:30. Now I do this for 3 months. Now the system will understand that at 6:30 I am turning on my water heater, and what it does is essentially it will start automating. So every day 6:30 it will automatically turn on the water heater for half an hour and it will turn off. So it is optimizing, it is detecting patterns, it is detecting some kind of algorithm around that, right? So this is done by data scientists, right? And for non-tech roles you have business development manager who would create use cases or case studies around business, right? So if you are from non-tech background, right, if you are already doing some marketing or sales, it's essentially just selling services and things around IoT. So definitely understanding the system goes long way, because you already have a niche. You understand logistics, you may understand supply chain, you may understand some specific industry. If you tag it along to IoT, you have the skill set, you have everything that you need to create a valid business. You can see that how IoT can solve problem in your specific field, right? So this is and then marketing and sales around your IoT products and your IoT portfolio. It can be services, like your company can maybe a software company that can transition into selling IoT softwares, or making this IoT system. And you can also sell around some of the case studies, business cases, and get your company to market it or make it. And you can also sell IoT products as well. There are really good products. So Fitbit is one example. Your smart speakers, smart systems that can turn on the fan or detect specific temperatures or specific things around environment, is also another kind of product. There are a lot of Kickstarter products, Indiegogo products, or products on these platforms that you can find developed by individual or smaller companies that are being sold and marketed individually. In fact, even in bigger companies, they are selling cloud services, they are selling some or other form of components in IoT, hardware or software. Then you have industrial designers. So if you have seen some kind of product, the outer enclosures, the casing, the look and feel, is done by industrial designers. So it is just that they do their job, they design products. For IoT, there are some specifics, right? So it has to be some kind of environment protected. It will be outside or inside. How it will be mounted. So there are just some constraints that come in IoT. In fact, a robot can also be an IoT device. So industrial designers tend to design these products, right? Design the look and feel, how they will look, right? Then you have mechanical engineers who are responsible for actually engineering it, right? Making it happen, making or going through constraints or changing something. So one aspect is design, and another aspect is mechanical engineering, where they tend to solve these problems of manufacturability, that it should be manufacturable, mass manufacturable, right? So if you are a mechanical engineer, you can also look towards transitioning IoT. So business analysts are the people who create cases or find trends in the industry around IoT. For example, there is a client, or if you have a client that wants to use IoT, and you are already doing some kind of business analysis where you are doing some market research, you can always see that how IoT can help you to solve this problem, right? And then you have machine learning engineer that I've already explained, that our data scientists will understand patterns. ML or machine learning engineer will actually derive some kind of intelligence from that data, right? So you already have data. You One aspect is analyzing trend and giving decisions. Other aspect is using that data to derive new data, or derive new patterns or create possibilities of what is possible from this data, right? So for example, in the earlier example, we saw how in agriculture it can detect diseases, it can detect patterns, it can give warnings. So those kind of systems are usually built, or the algorithms are built by machine learning engineers. And then you have IoT trainers, right, in this specific field. So IoT trainers are essentially required. if you are a teacher or if you are already teaching in some kind of school or university, this is something which you may find relative. So IoT is just a skill; it can be learned, and there are a lot of requirement for trainers as well. People who can train the next generation of engineers. So you can teach the entire system. You don't have to be very specific. You can teach them on the basic level, and they can explore their path from now. So you need IoT trainers in each category or as a overall for creating the next generation of IoT engineers. And then you have service engineers, engineers that will basically help to service this IoT devices in the market, right? So in the similar way, your normal products works is you install a air conditioner and you have few people who would be servicing your air conditioners or HVACs or heating system. So for IoT as well, you will need service engineer. It's essentially the same. It's just that they have an added skill of how to enable these devices or how to onboard them or how to connect them to the internet on the application level. Those are usually done by service engineer. And then you have a very component or very important role as well, which is domain expert, right? So it doesn't matter which background you're from. If you have like years of experience in your specific domain, it can be logistics, it can be any domain, and you can basically transfer those skills, carry those expertise and niche, and tag it to IoT and make your profile really appealing. So the industries require experts to help them understand the process because you understand the process better. In fact, you understand the process better than them. You know what are the issues that are in the process and you know how to fix them. And you can also help them that how these processes can be fixed with the help of IoT. That is why domain experts are really highly sought out members or positions. They are paid really good and they can leverage their existing skill, create a niche. These are few of the career landscape or a few of the career options in this overall landscape that you can look towards or see towards, right? So if I were to talk to that, the salary ranges, right? So for a tech role, it can easily start from around 40 to $50,000 to I have seen somebody get paid like on the architect level who designs this entire system around one and a half million dollars. I know few people personally who have created some products around IoT, and they are earning around $6,000 to $7,000 per month as a side hustle. I know business analysts who have transitioned from logistics or manufacturing background to IoT, and they are almost double their salary. There are hardware engineers I know who transition from basic system to IoT system, essentially doing a skill stacking or leveraging their existing knowledge, in IoT and doubling their income. It's applicable for all the other roles, so it doesn't matter which role you are part of. If you tag it along with IoT, if you learn IoT as a skill, and you can then transition into IoT role along with your niche, along with your expertise, you become a really good niche, right? There would be hardly few people that have or that carry these two skills. So these this is the landscape, and this is in short, I just tried to give you brief about what is a horizon, like what are the aspects in which you can grow, what are the job opportunities and role in the overall IoT ecosystem. Now, this is the end of the course. I hope that you enjoyed this overall courseware. So, what my intention of this course is that even if I am able to manage 1% of the audience who have purchased this course to get into IoT, to learn more about IoT, or even increasing a slight chance for them to get into IoT field, I have already achieved my goal. So you can always reach out or comment in the forum if you come across any questions. So thank you so much, and I hope you have a really good journey in learning IoT.